The numerical model is the physics of movement. So the model measures the physics of how your body moves in a numerical form when doing specific skills and techniques. The numerical model would mainly be used at an elite level so that the content is good quality, and because it is an academic and complex process by which it would not be useful for cognitive learners as they would not understand the process and it would not benefit them. The numerical models can be created by using quantitative forms of data. Like the other models, the data can be collected and created from elite athletes' performances by analysing video captured from different angles, or the subjective or objective knowledge of the person analysing, or from researching from specific articles relating to the information you want to know. The numerical model can be useful if executed correctly. You need to make sure that the method on how you set up the camera is right, as this could hinder the effectiveness of the model. Also, you need to make sure that your participants know what they're doing so that they don't cause any errors. The model can be most effective when the equipment you are using is specialised to what skill the performer is doing. This means the recording equipment and the right equipment in order to complete the skill accurately. The most accurate results come from 3D imaging, as this gives the athlete's performance in detail. Therefore, you can analyse things such as the angles of their joints when they make certain movements. Kinetics of the forces applied to an object to make movements or change happen. An example of this is a mass of an object. The mass of an object is how much matter the object has, how much of the object there is. By changing the mass of an object can affect someone's performance. For instance, in basketball, if we change and increase the mass of the ball, we will also consequently increase the weight of the object, meaning that the ball will be heavier for the athletes to lift to the hoop, resulting in them having to use more force applied to their shot to get the ball into the hoop. This will maybe affect their performance as they might miss some shots. Kinematics are the motions that a body or object make. Linear motion is a straight line movement. All body parts of an object move in a straight line at the same rate. Angular motion is movement around an axis. That can be around a joint axis or an equipment's axis. An example of this would be flexion of the arm at the elbow, or either the rotation around the uneven bars in gymnastics. General motion is a combination of linear motion and angular motion. Projectiles are objects where the only force acting upon them is gravity. Scalar quantities are quantities that have magnitude only. They are elements that have a numerical data associated with them. An example of a scalar quantity is mass. For example, the mass of a basketballer is 63 kilograms, compared to the ball, which is 7 kilograms. This data only shows you how big, so the magnitude of the person and the object. However, in contrast, vector quantities have both magnitude and direction. This means that it is numerical data in a given direction. An example of a vector quantity is weight. The weight of an object is the overall mass of an object and the force of gravity acting upon that object in a given direction, so down. So it has size and direction. An example of this in basketball is when the ball is bounced. During when it is travelling towards the ground, that is the force acting upon the ball. Speed is the rate in which something or someone moves or operates. It is the distance covered by something per unit of time. It is a scalar quantity as it only has magnitude. An example of this is if a basketballer travelled at 4 meters per second. Velocity is the rate an object moves or operates in a given direction. It is a vector quantity as it has both magnitude and direction. For instance, in basketball, if the player sprints for the ball at 4 meters per second in the given direction of east, then this is their velocity.